Okay, so knowing what we know, let's go ahead and put it into practice by solving a couple of linear systems. So the idea is each equation represents a line, so we're going to graph the line and then see where both lines intersect. And that's how we're going to find the solution to our system. So taking this first equation, as we saw, the quickest way to do it is to put it in good old y equals mx plus b. So we'll subtract 2x from both sides. That leaves us with negative y equals a negative 2x plus 6. If we divided both sides by negative 1, we get y equals, well, a negative divided by a negative is a positive, and a positive divided by a negative is a negative. So this is telling me that my slope, right, is 2 or 2 over 1, and my y-intercept is at 0, negative 6. So I can come to my grid, 1, 2, 3, 4, 5, 6, right? So there's the y-intercept, and then the slope's telling us to go up 2 and over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. So there, again, graphically, is a picture of all the solutions to the first equation, 2x minus y equals 6. But we have another equation. Right, so what about x minus y equals 1? Well, again, putting it in slope-intercept form, we'll subtract x and then divide by negative 1, and we get y equals 1. Negative divided by negative is a positive, and a positive divided by negative is a negative. And so in this case, our slope is 1, or 1 over 1, and our y-intercept is occurring at 0, negative 1. So I'll come over here and come to here's 0, negative 1, but my graph is basically telling us to go up 1 and over 1, right? Up 1 and over 1, up 1 and over 1, right? Up 1 and over 1, and then up 1 and over 1. So when I graph this, right, there's the solutions to x minus y equals 1, and it does look like they're intersecting right at that point, right there. That's where both graphs share a common solution point. And it looks like that's at 1, 2, 3, 4, 5. And then 1, 2, 3, 4. So it looks like 5, 4 is our solution points. Of course, how do I check it? Well, 5 take away 4 is 1, so it checks that one. 2 times 5 is 10. And if we subtract 4, we get 6. So it does check both of them, so that tells me we did a good job. We graphed it right. We found the solution points. And again, the graph is telling us that that's the only one. So we'll just keep on graphing. So for the next one, again, we have a couple of equations. So what we want to do with each, let me go ahead and write them both at the same time here. We're going to put them both in slope-intercept form, and then we'll put them together on the graph. So over here, I'll subtract 4x. Gives us that. If we divide both sides by negative 3, I get 4/3 x, and I believe plus 6. So this guy has a slope of 4/3 and a y-intercept of 0, 6. How about, let's stay here and keep on working. So we get y equals negative 2x minus 4. So this is telling us our slope is negative 2 over 1, and our y-intercept is 0, negative 4. All good? So let's go do some graphing, right? So this first graph, 1, 2, 3, 4, 5, 6, we have a y-intercept at 0, 6, and then the slope's telling us to go 1, 2, 3, 4, and over 3, or we can go down 1, 2, 3, 4, and back 3. 1, 2, 3, 4, back 3, right? So I'm using a negative divided by a negative is positive. So here is a picture of all the solutions to the first equation. What about the other equation? Well, we're going to start at 1, 2, 3, 4, 0, negative 4, and then the slope tells me to go down 2 and over 1, or we can go up 2 and back 1, up 2 and back 1, up 2 and back 1, right? So I'm just using the fact that negative 2 over 1 is 2 over negative 1. So we can kind of see, right, there's all the solutions to the second equation And they do in fact have an intersection point. 1, 2, 3. It looks like at -3, 2. All right, and so that basically is the ordered pair that solves it. So again, just a real quick check. 4 times a -3 is a -12. 3 times 2 is a -6, right? And so that's -18. 2 times -3 would give us 6. We add a 2, and we get a -4. So it checks out. So we basically, oops, I missed. Sorry about that. So I basically was just checking to see if it works, and it makes them both true. So that's how you solve a system by graphing. Graph both lines, see where they cross, and that's your solution point. Right? We'll continue to work some more examples.